I'm Chris.
I'm Will.
I'm Sam.
And today we're going to be covering Chapter 2, where we'll talk about shifting, reflecting, and graphing complex functions, and then the domain and range of those shifted functions, and also piecewise defined functions. So let's take a look at this absolute value function, which is quite obviously not the same as its parent. Let's see what we have found and why it's different from its parent. First of all, you can tell up here that it has shifted up by 8 from its parent, which would usually start at y equals 0. We can also see that the overall function has shifted to the right 3 because the parent function should start at the origin 0, 0. And lastly, we can tell quite obviously that versus this normal V shape, it has been reflected across the x-axis to form more of a pyramid. So how these things relate to the overall equation of this function is that the fact that it's been reflected across the x-axis will mean that the overall function will be negative f of x. The shift up by 8 will also indicate that the overall function will have a plus 8 at the end. And the shift to the right by 3 will mean that inside the absolute value there will be a negative 3. This should lead to a new function of this precisely. F of x equals negative absolute value of x minus 3 plus 8.
So we know that the parent function has been shifted, but how does this affect the domain and range of the function? The original domain of the function is negative infinity to infinity, and the original range is 0 to infinity, which would look like this. Generally, ranges are the only thing that are affected by shifts and reflection. And in this case, that's true. Before there was an absolute maximum, there was an absolute minimum at 0. Now there's an absolute maximum at 8. We also see that the function is pointing downwards, which means the range is reversed. Okay, now let's look at the new domain and range of the function. So we know that the domain stays the same, but that the range has been shifted up 8 spaces.
And that's the end of our first example. Now we're going to move on to piecewise defined functions.
Alright, this is our piecewise defined function, and first we're going to find the domain of each function. For 2 plus x, if x is less than negative 4, the domain must be negative infinity to negative 4 because of the parameter. Likewise, for negative x, if negative x is less than or equal to x, which is less than or equal to 5, the parameters are between negative 4 and 5. And for x, if x is greater than 5, then the domain must be 5 to infinity. Now, how to graph the function. Each equation will be shown on the graph within the given restraints. Here are our graph functions within the given restraints. As you can see, for x plus 2 when x is less than negative 4, there is a circle here because x is less than negative 4, not x is less than or equal to negative 4. This means it is not inclusive of negative 4. For the segment negative 4, if x is less or greater than or equal to negative 4 or less than or equal to 5, we have a segment here with 2 solid dots or points. These are inclusive, and it's inclusive for throughout the entire line. Then for x, if x is greater than 5, it is not inclusive of 5 because it's less than, not less than, because it's greater than, not greater than or equal to 5. And it's every point after that. The range of all the segments is negative infinity to infinity. The domain starts at negative infinity to negative 4 because of this function, and then there's a union to negative 4, comma 4 with brackets because it's less than or greater than or equal to or less than or equal to, and then a union to 4, comma infinity. Now if you want to take a graph like you see here and turn it into a function, what you would need to do is first set up the parameters. So you'd have negative infinity to negative 4 with the circle here, so you know what the domain and range of that is. And then with this segment here, you could also do the same, and also with this line here. So once you have those parameters, you just figure out the equation of each line and segment, and by that you can find the function and the equation of the piecewise defined function.
Thanks for watching this instructional video. Hope you learned something, you silly pooch.